Questions 29 and 30. A 6 kilogram block moves with a constant speed of 5 meters per second on a horizontal frictionless surface and it collides elastically with an identical block at rest. So this is going to be an elastic collision. The second block collides and sticks to the last 6 kilogram block, which is initially at rest. So this is going to be an inelastic collision. Number 29, what's the speed of the second 6 kilogram block after the first collision? Well, since it's an elastic collision, we can use our equation for elastic collision, which is V1 plus V1 prime equals V2 plus V2 prime. So let's see, we have V1 prime after it collides, well, let's see, V2 initially at rest was 0. And after V1 collides elastically with the second block, its final velocity will be 0. So we're going to say that the velocity, final velocity of the second block is going to be the initial velocity of the first block, which was 5 meters per second. Another way of saying is the little trick that whereas if we have equal masses colliding elastically, they switch velocities. So this velocity initially was 0. It's going to switch with the block coming in, so it'll be 5 meters per second after the collision. And the first block that's coming in will switch with the second one, and it will be 0 meters per second after the collision. Number 30, what's the speed of the third 6 kilogram block after the second collision? All right, so we're just interested in this portion here. So we can say, all right, so we have m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime. Well, let's see, initially the second mass, which is the third one in the whole scheme of things, was not moving. And what's going to happen is the two masses are going to combine, because it's an inelastic collision, they're sticking together with a final velocity. So final velocity is going to be equal to m1 v1 divided by m1 plus m2. So m1 we said was 5 times its mass of 6 is 30 divided by the two masses, which is 12, is going to be equal to 2.5 meters per second. Another way of solving 30 is by saying, all right, with with equal masses in an inelastic collision, that the final velocity of the second one is going to be half the velocity of the one that's coming into it in the collision. So that would be a neat little trick to use, or we can solve it using conservation of momentum for an inelastic collision.